Good morning. Today we're going to be talking about statistics in respect to theoretical probability. This is the measure of the chance some event will occur. Whenever you have all outcomes as equally likely, the probability is the ratio of the number of favorable outcomes. So this is really what you're wanting. So this is what you want to happen. Divided by the number of total possible outcomes. Now, whenever you have whatever you're wanting number divided by the total possible, you're going to get a fraction. And it's going to be between 0 and 1 as a fraction, decimal, or a percent. If, for example, I have a quarter, there is going to be two sides to a quarter. There's tails and there's heads. If I flip a quarter, if I choose either one of these, I have one favorable outcome, whichever one I choose, over the two possible outcomes. So the chance is 1/2. That is a very simple illustration just to get you geared to think about how we're going to be looking at problems today. Now let's look at the spinner. The spinner below is spun once, and we're asked to find the probability as a fraction or as a decimal, and as a decimal and as a percent. So, P, the probability that the number will be a multiple of 3. On the spinner, we have 3 to 16, so we have the options 3, 6, 9, 12, 15. 5 different numbers would satisfy this probability. So I have 5 over the 16 possible outcomes with this spin. This is equal to 0.3125. If I was to ask you this as a percentage, it is 31.25%. That is your chance of getting a number that is a multiple of 3. If I look for prime numbers, I have 6 of those out of the 16. This can simplify into 3/8. It can be written as the fraction 0.375 or 37.5%. Okay, C says even or greater than 5. Now I want to talk about this one just a little bit detail. This word or. I'm going to have two criterions in this. I have to account for both. The first would be even, so 2, 4, 6, 8, and so on. But then greater than 5. Greater than 5 means I'm not including this, but I'm including every number after 5. So I'm going to be including, because of that or, 10 numbers. $11 numbers. And then it says even. I am not counting the even numbers after 5 because of that or I already have all those included, so I don't worry about them. So I'm going to have 2 and I'm going to have 4, which is so another 2. This is 13 numbers out of my 16. As a decimal, it'd be 0.8125 or 81.25%. All right, that's how the word or works. You're using both of those together. D, though, says odd and at most 9. This one is a different type of constriction. Here's what the word and means. I have to satisfy both of those. So at most 9. I cannot use anything after 9. And now I'm gonna look at the odd part. Odd would be 1, 3, 5, 7, 9, which is 5 out of the 16. So 31.25%. Sorry, I skipped one. 0.3125. And now 31.25%. Okay, theoretical probability, there you go. Now let's look at some word problems. We just talked about spinning a wheel. Let's look at this. A pencil box contains 5 red, 12 blue, 10 green, and 3 yellow markers. If a marker is chosen at random, what is the probability that it is not yellow? Okay, not yellow is what I'm looking for. So I have a grand total of 5 plus 12 plus 10 plus 3 markers. So I have 30 markers total. Three of these markers are are yellow. That means the remainder of the markers, 27, are not yellow. My probability is 27 out of the total of 30. And this is equal to 9 over 10, which is 90%. Sorry, I just not read the top here. Questions in as fractions, the simplest form. My simplest form is 9 over 10. All right, number 3. What is the probability of drawing an ace or a diamond from a standard deck of playing cards? This requires you to know a little bit about playing cards. In playing cards, you have 52 cards. This is broken into 4 suits. You have diamonds, you have clubs, you have hearts, and you have spades. Each one of these have 13 cards in them. So, ace to king is 13 cards. What is the probability of drawing an ace or a diamond? So in the diamond set, I'm using all 13. For the clubs, I just want the ace, so I'm going to use the ace from this for 1 card. I'm going to use the ace from this one for 1 card. And the ace from the spades as 1 card. For a diamond, I'm using ace to king for all 13 cards. 13 plus 1 plus 1 plus 1. So 16 out of my 52 cards will give me either an ace or a diamond. This is 4 over 13. Simplified. Okay, Finn guessed on the last 3 true-false questions on his math quiz. What is the probability that he got exactly 2 questions correct? All right, let's break this down. You have 3 questions that are correct and incorrect. So 1 question, 2 questions, 3 questions. Now, we are going to see which ones he got correct. So we don't care about the true or the false, but we do care about the correct and the incorrect. So, for the first choice, he could get it correct, he could get it incorrect. Now, off of this, he has two more options. On the second one, he could get it correct or incorrect, regardless of if he got the first one correct or incorrect. On the third question, this is going to break it into even more options. Correct, incorrect, correct, incorrect, correct, incorrect, and correct, incorrect. Each one of these is a row, and we're looking for an exact probability of having exactly two questions correct. So, follow the chart. You can have two corrects and then get the last one wrong. So, that possibility would be correct, correct, and then incorrect. Or he could have started correctly, got the next one wrong, and got the final one correct. So correct, incorrect, and then correct. The last possibility, he could get the first one wrong, but then get the next two correctly. So that would be incorrect, and then correct, correct. Now, if you follow this tree on the last one, and I'm going to erase these markings real quick to make it clear. My final options, I'm going to have 2, 4, 6, 8 total different ways this could play out. To get exactly 2 questions correct, his probability is 3 out of the 8 possible situations. Okay. Real quick, if you are guessing on true-false questions, you do not have a good probability of getting them all correct. Anyway, 2 standard dice are rolled. What is the probability that the sum of the dots on the dice is at most 5? All right. 2 standard dice, that's from 1 to 6. If I roll a 1 on the die, I can follow that with another 1. That sum is 2. Or I can roll a 1 on the first one, then roll a 2. That'd be a sum of 3, a sum of 4, and then a sum of 5. All of those will add up to 5. On my first dice, if I instead rolled a 2, I could have a 1, I could have 2 2s, or I could have a 2 and a 3. That would give me 5, at most, for adding them. If I started with a 3, I could roll a 1, or I could roll a 2. Again, that adds up to at most 5. And lastly, if my first die was a 4, I could roll a 1 on the second one and be fine. 2 standard die are rolled. What is the probability that the sum of the dots on the dice is at most 5? If you count these situations, there's 4 on my first row, 3 on my second, 2 on my third, and 1 on my fourth. This is 10 total possibilities out of my total number of possibilities. To get that, I have 1 through 6 on the first die, so there are 6 possibilities. 1 through 6 on the second, that's another 6. I have a grand total of 36 different possibilities. Five over 18 is the probability that the sum will be at most 5. All right, we are halfway done with today. Let's look at the part-time job and driver's license. I'm sorry about that, excuse me. All right, students are asked if they have a part-time job and if they have a driver's license. The information on the left is a Venn diagram based on this information. All right, I'm going to be looking for each fraction in simplest form. So for part A, I'm asked which ones have a part-time job. In the middle, this 6 would be they have both part-time jobs and driver's license. They're included in both groups. So for a part-time job, I'm going to have the 8 that have just a part-time job plus the 6 that have both divided by my total amount of people, which is 8 plus 6 plus 7. Plus, because there's one more thing to look at, this 4 on the outside. These 4 students do not have a part-time job, nor do they have a driver's license. So it's 8 plus 6 plus 7 plus 4. This is 14 out of 25 total students. My Venn diagram, I can see there's 25 total students. There are 14 with part-time jobs. And there are 13 with driver's license. Okay? How many have no driver's license? So that's the 8 in the part-time job, plus the 4 with neither, which is 12 over my entire 25. They have a part-time job and a driver's license. That's the 6 in the middle out of the 25. D is part-time job or driver's license. This is taking both parts of the Venn diagram, but I'm excluding the 4 people who have neither one. So this is 25. So the whole group minus the 4 that have neither, or 8 plus 6 plus 7, either way it'll be the same answer, to get 21 over 25. E, they're going to have a driver's license and no part-time job. This is just the right side, so 7 out of 25. There you go. Out of 60 students, 15 are taking calculus and 17 are taking physics. 8 of the students are tracking both calculus and physics. If a student of this group is chosen at random, find each probability. I would highly invite you to pause this video, try to set up the Venn diagram, and solve parts A and B. All right, if you was going to do it, you have had time. So, let me make that rectangle bigger. There's my Venn diagram. I'm looking at calculus, physics, and then neither. So here's my calculus. Here's my physics. And then the outside of those Venn diagrams will be they didn't take either one. So out of 60 students, 15 are taking calculus, 27 are taking physics. 8 of the students are taking both physics and calculus. We're going to start there. So 8 is in the middle. Because if I have 15 taking calculus, I'm already using those 8. So for calculus, I'm going to do 15 minus the 8. And that's going to give me 7 students in calculus. For physics, I'm going to be doing the 27 minus 8. And that's going to give me 19 students taking physics. Now, if you add these up, 15 plus 27 out of the total 60 will leave me with 26 students in neither physics nor calculus. Okay, part A takes calculus or physics. This will be 15 plus 27 because we're taking both. This is 34 out of my 60 students. This is 17 out of 30 simplified. How many take calculus, but not physics? So this is going to be the 7 for just calculus, and not physics, over 60 total possibilities. So I just want the amount of people in calculus and nothing else. Okay, that's finished. Complement of an event. This is really, really easy because it's the same thing we just did, but I'm finding the opposite of my number. Here's what I mean. The complement of an event is the probability that the event is not occurring. It's not happening. The sum of every sample is 1, so any probability is 1. To find the complement of the event, you're just doing 1 minus the probability of it actually happening. So, for example, on part A up here, you don't have to write this, I'm just showing you an example. The complement would be 1 minus 17 over 30. So 30 minus 17 is how I can get that. And it's going to be 13 over 30. That is the complement. That's how many people would be not taking it, calculus or physics. All you're doing is subtracting 1. All right. The probability that it will rain tomorrow is 11 over 15. What is the probability that it will not rain? Here's the difference between complement of an event and just probability of the event. For a regular probability, I would say what is the probability that it will be sunny? Not raining means it could be cloudy outside. It could be snowing, but it's not raining. So the probability of rain is 11 out of 15. The probability that it's not going to rain is going to be 15 minus 11 over 15. 4 over 15. Finished. A number from 1 to 30 is selected at random. What is the probability of not selecting a multiple of 4? All right, multiples of 4 from 1 to 30. 4, 8, 12, 16, 20, 24, 28. There are 7 of those. So 7 out of my 30 numbers is my probability. Ooh, that was not supposed to be a B. Probability of it happening. My probability of it not happening is 30 minus 7 over 30. 23, sorry. (23 over 30 is the probability that it's not going to be a multiple of 4. All right. We've talked about theoretical probability. We've talked about complement probability. Let's talk about experimental probability. Here's what experimental is. It means I'm taking my theoretical probability, so what the expectation is, and now I'm actually running tests to see if I get it. Okay? There is something called the gambler's fallacy. What that means is, for example, if I buy a lottery ticket, it says I have a 25% chance of winning. If I was to buy 4 tickets, logic would say, well, that's 4 times 25%, so I have a 100% chance of winning. This is incorrect. That's called the gambler's fallacy. Every time you spin, so like on number, whatever this is, I guess 10. Every time I spin that, I have a 1 out of 5 chance to get a color. It does not matter if I spin this 1,000,000 times. I might never get the color orange if I kept spinning that. Okay? And I spelt chance wrong. But I might spin it a million times and never get one of the colors. What experimental is, it's saying if I were to actually start spinning this, how often would I hit it? So it's comparing what actually happened versus what statistics say theoretically would happen. So, find the theoretical and experimental probability if the spinner is spun again. So 10, probability of spinning an orange. Theoretically, orange is one color out of my 5 colors. So theoretically, it's 1 out of 5. Based on our experiment, we can see that orange is spun 12 times here out of my total spins, and I'm going to write total here just to make it easier for us. 5 plus 12 plus 7 plus 16 plus 10, 50, and also it's written right there, but anyway. So actually, in the experiment, it happened 12 out of 50 times, or 6 out of 25. So it happened a little bit more than a fifth of the time. Number 11, I want you to go ahead and pause the video and try these next to, see if you can get them. But number 11, the probability of it being red or green. Well, that's a 2 out of 5 chance. If I look at the red, I have 5. If I look at the amount of green, I got 10. So 5 plus 10 divided by 50, or 15 over 50, which is equal to 3 over 10. All right, number 12, not purple. The probability is 4 out of 5. If I was to take everything, add everything up besides the purple, I'm going to get 43 out of my 50 total. That cannot be simplified. I'm finished. We are done today with theoretical, complement, and experimental probability. If you have any questions, please be sure to reach out, and I'll be happy to answer them. Have a great rest of your day, and I'll see you later.